So we'll see the next concept, time taken versus efficiency. Time taken and efficiency varies inversely. So time taken and efficiency varies inversely. Say for example, there are two persons A and B. So if A is taking 10 days to do a work and if B is taking 15 days to do a work. So B is taking 15 days to do the same work. So A takes 10 days to do a work. And B takes 15 days to work. So in this, who is efficient? So obviously it is the person who takes less number of days to do the same work. So A is taking 10 days, less number of days. So A is more efficient than B, who is taking more days, that is 15 more than 10. So here the ratio of time taken is for A and B. So when you simplify 10 and 15, the common factor 5. So we get time taken ratio as 2:3. So to work out the questions involved with time taken and efficiency, so if time taken is given and if you need to find the efficiency, you have to take the inverse ratio. So if time taken ratio is 2:3, efficiency ratio will be, so as they vary inversely, it will be 1/2 is to 1/3. So now as you have only two factors, two parts, by cross multiplying, so efficiency ratio is 3:2. So when time taken is 2:3, efficiency will be the inverse of that. So ratio will be 3:2. Say for example, so if for two persons A and B, so if time taken ratio is 3:5. So what will be the ratio of efficiency? Suppose if you are asked to find the amount or wages received by A and B, so based on time taken we will not share the wages. So we will share the wages based on their efficiency only. So if time taken ratio is 3:5, so we have to find the inverse ratio, that is the efficiency ratio. So this is got just by interchanging the parts. So we have seen the working why we are interchanging the parts. So the ratio is 5:3. Suppose you have three persons, say A, B and C. So if you get time taken ratio as 3:5:2, so what will be the ratio of efficiency? That is the inverse ratio. So when you have two persons, we just invert the part. So when you have more than two persons, so don't just write the inverse order. So it will be 1/3 is to 1/5 is to 1/2. So whenever you need to find the inverse ratio, so the following steps are followed. So you need to follow the following steps. The first one is take reciprocal for inverse ratio. So to find inverse ratio, that is when time is given to find efficiency or when efficiency is given to find the time. So to find inverse ratio, the first step is you have to take the reciprocal. So this is for more than two persons. When you have two persons, invert the parts for inverse ratio. For more than two persons, take reciprocal. And then you have to take LCM for denominators. And then it should be written in a standard format. So standard format of ratios is avoiding fractions and decimals. So to find the inverse ratio, you have to follow these 3 steps. Take reciprocal, LCM of denominators, and writing in the standard format. But there is one easy method to find the inverse ratio where you can avoid all the steps. So to find the inverse ratio for more than 2 persons, for 2 persons we just invert the parts. For more than 2 persons, to find inverse ratio for A, multiply the other 2 parts. So 5 into 2 it is 10. And for B, multiply the parts of A and C. And for C, multiply the parts of 3 and 5. So this is one important question. So where time is given and efficiency is needed, and suppose when efficiency is given when time is needed, so instead of taking reciprocal, LCM and then writing in standard format, so for inverse ratio, multiply the other 2 parts, you get the inverse ratio. So by a single step you can get this. And now we'll see how to work out a question using this concept. If suppose efficiency is given, that is work is given, and if you need to find the time, say if ratio is 2:4:3, and to find the inverse ratio, multiply the other 2 parts, 12, and for B it is multiply the parts of A and C, 6, and for C multiply the other 2 parts of A and B, 8. So whenever you have common factor between 2 parts, so you will have common factor between all the parts in the inverse ratio. So just by simplifying that, you get the ratio for time taken. Here the common factor is 2. So inverse ratio, that is ratio of time taken, will be 6:3:4. So now we'll see an example. So the question is, A takes thrice the time taken by B. So if they are paid rupees 4,000, what is A's wages? So we'll see the working. So in this question, time taken is given and you are asked to share the wages. So based on the time, we will not share the wages. So we will share based on the efficiency only. So first we'll write what is given. So there are 2 persons, A and B, and the detail which we have is time taken. So A takes thrice the time taken as time taken by B. So ratio of time taken is 3:1. So to share the wages, we need the efficiency of B. So efficiency is inverse of time taken. So ratio will be 1:3. So just invert the parts for inverse ratio for 2 persons. So now we are asked to find A's share of wage. So when efficiency ratio is given, by merely seeing the person, you can't decide whether a person is efficient or not. So efficiency is got by or known by the work done by the person. So when efficiency is 1:3, so we assume that A has done 1 part of the work and B has done 3 parts of the work. So total, how many parts they have done? 4 parts of the work. So total amount for this 4 parts is given as 4,000. So dividing by total parts, the wages got for 1 part is 1,000. So as A has done 1 part of the work, he will receive 1 part of the share. So A share is 1,000 rupees. So if it is asked for B, B has done 3 parts of work, so he will receive 3,000 as his share. So here time taken is given. So for 2 persons A and B, time taken ratio is 3:1. So we need to find the inverse ratio, that is efficiency, to share the wages. So when time is 3:1, efficiency will be the inverse of that, 1:3, and A will get only 1 part of the share. So out of 4,000 divided by 4, 1 part is 1,000 and A receives 1,000 rupees. We'll see another example in time taken versus efficiency where 3 persons are involved. So the question is, in a given time, A can do half the work as B, C can do half the work as A and B can do together. So if C alone takes 40 days, find time taken by A alone to do the same work. So we'll see how to work this question. So we have three persons, A, B and C. So it is given that A can do half the work as B and C can do half the work as A and B together. And instead of taking all these fractions, I have told you to assume some work. So that will be easy for our working. So when A can do half the work as B, you assume any value for B, any comfortable value. So I will take B can make 20 toys. So any value you take, you will end up with the same ratio. So you take any comfortable values. So if B can do 20 toys, how many toys can A do? So A can do half the work as B. So if B is doing 20 toys, so A can do only 10 toys in that time. And now the other detail is C can do half the work as A and B working together. So A and B together, they can do 30 toys. Now how many toys can C do? Half of 30, that is 15. So whenever you take as fractions, all leads to complicated working. So this will be easier to work out. Assume any work done by B. So because B is the base, so based on that you can have work done. So work done implies efficiency, and we have 10, 20 and 15. So whatever common factor you have, you simplify, you can get ratio of efficiency. So what is efficiency here? The common factor is 5. So when you simplify, so it is 2:4:3. So whatever value you take, you will end up with the same ratio. Here we have got efficiency ratio as 2:4:3. And now we are talking about time. So efficiency given and time asked. So we need to find the inverse ratio. So for inverse ratio, I have told you how to work it out short. So just multiply the other two parts for inverse ratio. As time is asked, we need efficiency given, time is asked, we need the inverse ratio. So for A, multiply 4 and 3, 12. And for B, multiply the other parts A and C, 2 into 3, 6. And for C, multiply A and B parts, 2 into 4, 8. Now here you have the common factor 2, all are even numbers. So what will be the ratio of time taken? 6:3:4. So assuming any work for B, because B is the base, so we can easily work out this question. So we have got the efficiency ratio and we can find the inverse ratio by the short method. So inverse ratio is 6:3:4. So it is given that C takes 40 days to do a work. So we can see that 4 parts is time taken by C. So when 4 parts is 40, and how did you get this 40? So multiplying with 10. So 4 is multiplied with 10 and we get 40 days. And now you are asked to find time taken by A. So A takes 6 parts of the time. So if 4 parts is 40, we have multiplied 10 to get 40. Multiply the same 10. So we get time taken by A is 60 days. Suppose if they ask for B, B is taking 3 parts of the time. So 3 into 10, 30. So by simply finding the inverse ratio, so we have found time taken by A which is asked. Say for example, so instead of 40, so if it is given as 12. So if suppose C alone takes 12 days to do a work, so we have got time taken ratio as 6:3:4. So when 4 parts is 12, so how did we get this 12? Multiplying 3 with 4. And if you are asked to find for A, multiply the same 3 with 6, the common factor 18. So time taken by A is 18 days. So if they ask for B, multiply the same common factor 3. So time taken by B is 9 days. So now finding the efficiency given and time is R. So assuming any work for B, so we have easily worked out, found the ratio for efficiency and the inverse ratio, and the required answer is got. So if C takes 12 days, accordingly A will take 18 days. So if it is given 40 days, so 4 parts 40 means 6 parts 60 will be the answer. So by using this inverse variation, this shortcut method, you can work out the questions easily. So we'll see the next concept.